Our fourth lecture in the second unit of ATS 113 is all about precipitation, in particular how you get from the very small cloud droplets to the size of a raindrop that can actually fall and reach the ground. Precipitation droplets have to be pretty big because they've got to fall a long ways, and we don't want them to evaporate between the bottom of the cloud and the surface. So today's readings are going to be from pages 133 to 138, 188 to 195, and 202 to 204. Now the first little section here from 133 to 138 has to do with different ways in which droplets grow by condensation when water vapor just condenses onto the droplet. It seems like a pretty simple topic, but actually there's quite a few complications to how condensation works. And condensation is going to principally be achieved, as I've circled here at the top of the page in red, by cooling air parcels to their dew point temperature. And this is principally going to happen by lifting air parcels. So watch for processes that involve lifting in this section. Alright, so we're going to have reached their dew point. There's going to be condensation going on a droplet. But actually there's processes also trying to evaporate a droplet at the same time it's trying to grow by condensation. One process is called the curvature effect. So you can go ahead and skip page 135. And the other is going to be called the solute effect. Solute as in the sense of a solution. So you want to understand how the curvature effect makes little droplets very easy to evaporate. And so you either have to have, little droplets of pure water. So you either have to have very, very high relative humidities, higher than is going to happen in the natural world, or you need to have impurities in your water in the form of condensation nuclei. Because then, by the solute effect on page 136, you're going to find out that that having something dissolved into the droplet makes it harder to evaporate. In fact, some of these droplets won't even evaporate if the relative humidity gets to be less than 100%. That's how haze happens, for example. Okay, so there's going to be different kinds of nuclei, condensation nuclei and ice nuclei in the atmosphere. These are going to be little impurities, little aerosols in the atmosphere to which water vapor can condense onto. If they are an ice nucleus and the temperature is below 0 degrees Celsius, they'll form an ice crystal in the atmosphere. If the temperature is below 0 but they're a condensation nucleus, they'll form drops of what is called supercooled water. Make sure you understand the difference. Alright, then you can stop at the middle there of page 138 and jump ahead to page 188, which is on the chapter about precipitation processes in the atmosphere. Alright, so we go past this little introductory material, and we find out that there has to be growth of cloud droplets. Make sure you understand why droplets have to grow. I really like this figure showing the relative sizes of droplets, and there's a similar figure in your course CD. By the way, I've highlighted in blue here. There's an activity on your Aguado textbook CD that's really quite nice about precipitation. If you could answer all the questions on there, you'd be a long ways toward understanding the material for this section. Alright, so there's different processes. We just talked a little bit about the process of condensation, which is the principal process that's going to work in a warm cloud, a cloud in which the temperatures are above freezing. There's also going to be collision and coalescence when drops collide and hit each other and stick together. Don't worry about the text box at the top of page 192. And we're going to have these cold cloud processes, and most of the clouds that bring precipitation in our part of the country are cold clouds. Even on the warmest summer day, the tops of those thunderstorms are made of ice. They're cold clouds. Make sure you understand the differences between warm clouds and cold clouds. Alright, now I really highlighted here the Bergeron process, because this is going to be the key as to how cold clouds produce precipitation. You actually need all the processes of collision and coalescence as well as condensation, featuring both the curvature and solute effect, but the Bergeron process is really the key. And again, there's a demonstration on your textbook CD that's really quite good about that. And okay, you can stop there at the middle of page 195 and jump ahead to a little bit of material on page 202 to 204 about how we measure precipitation. This material is about just different kinds of grain gauges and how they work and things like that. Some of the more mechanically minded students often find this quite interesting, so we'll cover that material this semester. And you stop at the top of page 204. Okay, it's important material. Obviously in a class about weather we care about precipitation, so make sure you understand what's going on. If you don't, get a hold of me, let me know what's going on so I can stress the right material in class. And this has been Dr. John Truggy, copyright 2006.